So this is on your note page for this. These are the steps you're going to follow. For binomial probabilities, these are discrete. These are whole numbers. The reason we do this is because your normal curve is continuous. So for us to put discrete numbers on a normal curve, we said that, well, these discrete numbers would just be like this. They wouldn't represent bars. If I had 52, 53, 54, they wouldn't represent bars. So we're going to expand these to make bars because we have to make this into a continuous curve. So what you're going to look at is, you're going to verify that it is binomial. And do I have an N, a P, and a Q? N means two choices. How many trials did I do? My binomial means I only have two choices. I say yes or no, or whatever they're asking me for. My probability of success, my probability of failure. The next thing you're going to do is test this guy. You need to pass these two tests in order for us to say it approximates a normal distribution. If it doesn't pass that test, you stop. You say, can't do this. Okay? After that, once it passes this, notice this already is your mean. You already found your mean. N times P. N times P times Q is your variance. So all we have to do is take the mean, multiply it by Q. There's our variance. And take the square root of that guy, and that's your standard deviation. Those are the two pieces we need, a mean and a standard deviation. Before we go to your z-score, we have to correct your statement for continuity. Continuity meaning I need to make it into a continuous graph. It's a discrete statement right now. So I'm going to change my statement. I subtract 0.5 from the lower end. I add 0.5 to the upper end. I make my curve. I shade the way my probability statement says, whatever my probability statement is. And then I use my z-score formula. And I give my answer. So these are the steps that you're going to be doing. Keep this handy if we're following these steps. All right, so the first problem we have is this. This is on page 272. Sorry, 278. In a survey of 8 to 18-year-old heavy media users, is this the one I want? Yep. I think we did part of this before. 47% said they get fair or poor grades, C or below. You randomly select 45 8 to 18-year-olds heavy media users in the U.S. So am I talking population or am I talking sample? Stephen, what'd you say? Population. We are talking population. Okay, you're selecting N, but it didn't say a sample of, you're just selecting 45 people from it's going to be my N, but you're selecting 45 from the population. I'm not taking different samples and taking their means. This is back to normal z-scores. And you asked whether they got fair or poor grades. What will their answer be? Yes? No. Is this binomial so far? Okay. What is the probability that probability, how do I say fewer? Less than 20, say yes. So my N is 45. That's how many times I'm doing my trial. This is not a sample size. This is how many I'm doing my trial. What's my P? What's the probability that they said they got fair or poor grades? 0.47. What's my Q? 0.53. This is 1 minus. We did this the other day. We're just taking this further. So this is how I start. Then next, I need to say, I do have a binomial. I need to test N times P greater than or equal to 5, N times Q greater than or equal to 5. I determined, yes, I have a binomial situation. So I need to test. So I say 45 times 0.47. Is this greater than or equal to 5? Yep, it is. And this equals what? 21.15? And yes, it does. I say n times q. Now, do I really need to multiply this out? No, why, Chris? Why don't I really need to multiply this out?
That number's less and it's greater than 5.
Good. This original p was less than 0.53, and it was already greater than or equal to 5. So if I multiply by a larger number, shouldn't that also be greater than or equal to 5? So I say, yeah, of course this passes the test. So I've already passed, I found its binomial. I found that I passed the test. I identified all my players here. I write my probability statement. What's next? Get your chart, your steps. What's next? I'm ready to go, except I have to do one thing. I have to correct this for continuity. So yeah, so I'm coming up here to 18, 19, 20. Can I use 20 when I say less than 20? So I'm getting rid of this guy to start. So my highest number is 19. So the rule is subtract 0.5 from the lower, add 0.5 to the higher. So here's my correction for continuity. Will I ever find 19.5? No. The first number that I will hit, whole number, is 19. Isn't that what I expected? So now we're good. So now we're back to our z-score. We're going to sketch. Let's sketch this. Here's my mean. We just found, oh, okay, sorry. Your mean. We found your mean up here. Now your standard deviation is going to say 21.5 times q. Take the square root of that. And because my mean is 2 decimal positions, but my statement here is 1, I'm just going to cut this mean down to 1 decimal position. So I'm going to make my standard deviation 1 decimal position. Try to keep them all the same if you can. So what does this come out to be? 3.4. I did 2 decimals, but I think we should just do 1 decimal. Let me do n times p again. So 3 point, it should be, so 3.4 is fine. Okay, so now, you're going to put your mean here, which is what we found, 21.2. I need to go down, so I'm not even going to add my numbers going up. I can just subtract them going down, right? This isn't 19.5 just to the left. You can do the whole sketch if you want to. Just start at 21.2 and subtract your standard deviation. Remember, this is your population again. So I should be good once I do this. And I'm at 14.4 and so forth. I'm pretty good. This way I could see where my z-score is. So I find my 19.5 somewhere in here, and I say less than. Should I be greater, should my answer be greater than 50% or less than 50%? Less than 50%, good. So I'm going to plug it into my z-score, and I'll show you, you can still use your calculator for this once you reach this point. So your x minus the mean over the standard deviation. We know your x value. What is your x value? Yeah, the one we corrected, 19.5. That's why we do this. This buys us a little extra space, doesn't it? Minus my, what happened? Oh, okay. All right, so let's calculate this. We good? You're welcome. So you get a z-score, you get a z-score of negative 0.5. Did I expect my z-score to be between 0 and negative 1? Yes. Yep. So what's my next step? Move on. Go to my table. I gotta find the area. Same as you used to do before. So go to my table. So Olivia, can you go to the table for us and tell us what the area is to the left of negative 0.5? So go in the back of the book. What do you get, Sarah?
0.3085.
0.3085. Thank you.
Wow.
So, did I say less than 50%? Was I good on the less than 50% on my estimate? Yep. If it was greater than 50% the other way, I would say, oops, I forgot to subtract it from 1. Okay, so we're good with this? So, basically, this part stays the same. This part changed. This changed. This changed. And my mean and my standard deviation, I had to find myself. Now, if you put this on your calculator, once you find your mean and your standard deviation, you can bypass that Z-score business. Your lower limit, negative 999. Your upper limit is 19.5. Your mean is 21.2. Your standard deviation, 3.4. And you paste. And you'll get your area. And the rounding sometimes is a little bit more exact on your calculator because they don't round on, they don't estimate on anything. But if you're close, just tell me you used your calculator. So you can still use your calculator for your Z-score. You still have to find your mean, you still have to find your standard deviation, you still have to correct for continuity, you still have to sketch. Good? It just gives us a few extra steps. There's no sample here. It's an N. It's the amount of trials we're doing. We're pulling, like Stephen told us, from the population. So that's the difference. We're not doing divided by the square root of N. We're not doing that part in here. This goes back to regular. Okay, so you guys so let's talk a second. Within 100, they're doing this 100 times. What's P? What's Q? So is this binomial? Are they responding? Are they giving me two choices? Yes, no. Okay. What is my probability statement? Okay, so we'll keep 30 right now, okay? We'll correct it in 1 second. All right, so I have a binomial. Yeah, I'm going to test in a second. We have a binomial. We have a question that they're asking us. Chris says I forgot to test, so let's test. So do we pass the test? 100 times 0.34. This is nice. Yep, this passes. So what is my mean? 34. So my standard deviation will be the square root of 34 times 0.66. And your mean should be 1 decimal place more than your x values. Your x values are discrete on these. So your mean should be 1 decimal place. It just so happened to work out perfectly. So make your standard deviation 1 decimal place, because that's what your mean should be. So your standard deviation should be what? Anybody get a standard deviation? 4.7. Okay. So we pass both tests. We know the second one will pass, right? Because I'm multiplying it by a larger number. So that should definitely pass. You notice when your n's are high, you're going to pass. Sometimes what happens is one probability is very low, like 5%, 0.05, and one is 0.95. Sometimes that 0.05 doesn't make it, so always test the smaller. So we're gonna correct this for continuity. So I'm greater than 30. So I'm going to start here like this, just because I'm going to use 30 and see if I need it. Can I use 30? I have to be greater than 30. No, I can't use 30. I always start with whatever number they give me, and I say, can I use that one? Can't use it. So this is my first number. It's on the left. So what am I going to do to that? Subtract 0.5. So Sarah told us 30.5, right on the dot. You have a couple of things before you can get to that Z-score. We're going to sketch. We're going to put our mean in the middle. So since I want to go down to 30.5, I'm just going to subtract my 4.7. If I subtract 4.7, I get 29.3. That's as far as I really need to go. I just need to know where is this falling. So 30.5 falls somewhere here. And which way do I want to shade? To the right or to the left? To the right. So should my answer be greater than 50% or less than 50%? Good. So I approximate this to be greater than 50%. That's more than half my curve. So now I use my z-score formula. You're welcome to use your calculators if you like your calculators. My x value is this guy, the one we changed. My mean, my standard deviation. So what's your z-score? Negative 0.74. Good. Did I expect it to be between the 0 and the negative 1? Yeah. Now, when I look up that area, I get 0.2296. I said, I expected my area to be more than 50%. Minus it from 1. So now I know that can't possibly be that little. It's 7704. So I have a 77% chance of having more than 30 people respond yes to this situation. That they seen a person walk in front of a moving vehicle on a cell phone. And scare us. Okay? We added a couple of steps in there, but you have to put them in there. Okay, let's hit an at least, and then I want to hit an equal. I want to hit an equal one too today. My goal today is to get through these, at least most of them. Maybe we'll get the equal tomorrow. But then I'm going to give you an assignment tomorrow in class. We'll go over it Monday. We'll do a review on Tuesday. I'll have you do a review in class. We'll go over that. No, not Wednesday. We'll go over that Thursday. Half day. We do. We meet 1, 2, 3, 9.
Oh, it's 1, 2, 3, 9.
1, 2, 3, 9. Well, what happened when they did 9, 1, 2, 3 a couple years ago? Everybody that didn't have a 9 period didn't come in. So we have a lot of seniors that don't have the upper period. So they just flash back them in for 1 period, you know. So they didn't come in. But remember, we used to do 3. We did 4, but you only were in your 4th period for 10 minutes, 15 minutes, whatever the thing was. So we do 1, 2, 3, 9. So I won't count on you being here. So we'll figure. Unfortunately, this will drag out till Friday. Will be the test. That's why I give you a little review on Tuesday. We'll go over it Thursday. Test on Friday. Okay, so let's hit another one. 58% of adults say that they never wear a helmet when riding a bicycle. Yeah. So this is what the population came up with. What's Q? 4.42. I subtracted from 1, right? Okay. You randomly select 200 adults. There's my N. And you ask them whether they wear a helmet. They either say yes or no. What is the probability that at least 120 adults will say yes, that they never wear a helmet? How do I write that statement? At least.
Oh no, greater than.
Greater than or equal to 120. So first thing I'm going to do is test. I know this, well, first thing I'm going to do, I determined this was binomial. They asked me a question, I have a probability statement, so I'm going to test. And I like to test too because this is my mean. I already took the shortcut to my mean. So my N is 200, my P is 0.58. Yes, I passed the test, and this guy too will also pass the test. So I find my mean for this guy. So the mean is your N times P, which will be 116. So my mean is 116. My standard standard deviation is n times p, which I know, times q, God bless you, square root of that, and your standard deviation comes out to be 7 because it's 6.98. So I'm going to round it one decimal place, so I'm going to come out to be 7. It's like 6.98, so when you round it to one decimal place, you have to go to 7. I'm almost there. What do I have to do next? Good. So we're going to correct for continuity. So I'm starting with whatever number they give me, and they say greater. Can I use 120? Ah. It says, yeah, at least says greater than or equal to, right?
119.5.
Okay, but can I use 120 in my regular statement, right? I determined that, so now I know my left end, I drop it 0.5. So my new probability statement will be 119.5. First, before you correct it, determine if you can use those endpoints. If there's no equal sign, you can't use those endpoints. Get rid of them.
Explain why it's 119.5 then.
Yes, because at least 120 says, if I have at least $120 in my pocket, could I have 120?
Yeah.
So I can have that or more.
Yeah.
So that means this is what my situation is going to look like. I could have 120, 121, up and up and up. So I'm allowed to use this because it's equal to. I take the lower end, it's a lower end, and I drop it 0.5. I just say 120 minus 0.5. That's my correction for continuity. Because I am a discrete value on a continuous curve. So I have to correct this for continuity, otherwise my bar at 120 starts here. My bar should be around this guy. So I'm missing that little bit of area there. This gives me a little bit more area to me, a little bit more
But if you
percentage.
only have at least 120, how could you have 119.5?
Well, I can't. Will I ever hit 119.5?
But you have it written there.
Right. But in reality, I will never hit this number. I will always hit 120. But look what it does to my area. It gives me just a little bit more area. My problem is my discrete numbers sit on my graph as little lines. They're not bars. I need these guys to be bars. I need my normal curve to be continuous. I need them to have bars. They're not, because don't I usually have decimals on there? Right? So if I have decimals, that means they're continuous numbers. If I'm discrete, it means I'm jumping over all those decimals. So I want to make them into bars. I want to expand them. I'm not going to go expand each individual one because this is going to be the rest of this. So I don't need those bars there. But I do need to worry about my end bars. I need to just give them a little bit more advantage there. That's where that's coming from. So now I sketch. So now I put my mean here, 116. So I want to get to 120, so I add 7. And I should be good here if you want to go further. So now I say 120 falls right, 119.5 falls right in here. This is my 119.5. I want it to the right. Should my area be less than 50 or greater than 50? Less than 50. So now I use my z-square formula. So I've got 119.5. Don't forget to use that one. Over 7. And what does your z-score come out to be? 0.5. 0.50. Just make it 2 decimal places so it's easier to look up. Now when I look this area up, this is what I find. Because that puts me into the positive where I expected it to be. But I said, well, my area should be less than 1.
Yes.
Less than 50%. So I got to subtract it from 1. And there's that number again. Okay? Remember before it was the negative 0.5? Had the same area? But do you see what we did here? The correction for continuity is tricky. You have to make that have a bar. I don't care about all these little bars over here because I'm hooking them up into that whole area. All I care about is my end bar. Same thing that happens on the other side. If this is my bar and I'm less than, well, you missed this little piece of bar out here. So give it back to me. That's all I care about is that last bar. All the in-betweens are getting taken up in that area anyway. do the next one because it's basically doing this, but the statement changed. So let's just correct your statement here. So how do I say at most? Less than or equal to. So John, I'm here. I'm going to get the same information because it's the same problem, the mean, the standard deviation. But let's correct this for continuity. So I'm going to start like this. I can use 100, 99, 98, all the way down, right? In reality, can I use 100?
Yeah.
If I say at most 100 people?
Yeah.
Yep. So I can keep this one. So it's the right side. So what do I do to this guy to correct it for continuity? You add 0.5. And then the rest of it works the same. So we see that? Okay. All right, tomorrow we're going to start with the equals because the equals works a little bit different.